Good everyone, my name is Graphics. In this video, we want to analyze this circuit using Thevenin theorem. Now the question is that we should look for the amount of current that this resistor is going to receive, right? Now we have three voltage source and we have five resistors which has resistances of 0.5 ohms, 5 ohms, 0.4 ohms, 4 ohms, and 0.25 ohms. Now, this will guide you on what to do whenever you are going to use Thevenin theorem. Now, the law simply states that we know that V is equals to what? IR, right? And that is what? That is Ohm's law. Now, in Thevenin theorem, it's making us understand that our voltage will now be called the Thevenin voltage, VTH, equals to the current will now be the current that will be flowing through the resistance or through the resistor that you want it to flow through. We'll call it the what? The IL, right? The current flowing through the load because resistors are in form of load. Now multiplied by the Thevenin resistances, which will be in series with the load that you want it to pass through. Is that taken? So on the long run, we will now say that the current that we're looking for that is flowing through the load that we want it to flow through, or that it is flowing through, will now be equals to, if I divide both sides by RTH plus RL, we'll be having what? VTH, right? All divided by RTH plus what? RL. So this is what we are focusing on. This is what we are focusing on. So for we to be able to analyze this circuit, in order to look for the current that is flowing through any of the resistor that we want to choose, but for now we are choosing the 4 ohm resistor. Another time it might be the 5 ohm resistor, it might be the 0.4, so it depends on what we are flowing through. So but what we are looking for, what through the 4 resistors. So we know that our RL, right, is equals to what? The 4 ohms, because that is what we want to analyze here now. So what you do is, first thing we need to do, we need to what? Remove the load that we are told to what? To look for the current flowing through it, right? So we want to remove this too. So I'm going to remove this 4 ohms and I'll be having this. Now, I have removed it, so I'll call this my V, my A, and what? My V. So I'm going to write what? My VTH here. Is that taken? So this is VTH, which is this VTH here. So we need to look for this VTH, right? So the next thing we'll now do after we have replaced this resistor with our VTH here, we're now going to calculate for what? The VTH. So calculating for the VTH, calculating for what? The Thevenin voltage, right? So we'll move forward. Now when we get here, we're going to apply, we have, this is, let's call here to be P, here to be Q, here to be R, S, T, and what? And V. The reason is this, or let me call it W. The reason is this. We want to consider P, Q, T, W, P using KVL, as in Kirchhoff current law or Kirchhoff voltage law, we want to consider this loop here, right? So I'll write it that considering loop P, Q, T, W, P. So that means I'm going in this manner. I'm going in a clockwise manner this way, right? So I'm coming in this direction. This is how I'm coming. This is how I'm coming. And this is how I am coming here, right? So I'm going in a clockwise manner. Now we know that current moves from a lower potential to higher potential, right? So I'll be having 26, that will be positive. Now if I'm moving, what is moving here, since it's, we'll call it, let me just see my IA, right? So since we're moving here, 26 minus, there will be a voltage drop here, that will now give me 5IA. Because of voltage drop, that I'm putting negative. Now this is also negative to what? Positive. So you're moving from lower potential to higher potential. So we have plus 18, right? Now we're coming down here to minus what? 0.4 IA, right? Then we're coming here also, we're having minus 0.5 IA equals to what? 0. Right? If I decide I can use IB or anything, but this loop represented by, we'll say the current flowing through is IA, right? Now, if you look at this closely, we'll collect like terms. And what we collect like terms, what we're going to be having here is going to be 26 plus 18 will be 44, right? Then minus 5A minus 5IA minus 0.4 IA minus 0.5 IA will give a what? Minus what? 5.9 IA equals to what? 0. Now if this come here, we'll now say that the 44 will now be equals to what? 5.9 IA. So my IA will now give me 44 over 5.9. That will now give us what? So we're going to be having 7.458. 7.458 ampere. That is the current in this loop. Now we'll use the current in this loop to calculate for the VTH in the other loop, right? So when we are doing that now, where we start, right? So we apply KVL in this loop. I'll be going in this manner. Is that okay? So we'll go in this manner. Now if you notice it, current will tend to flow from a lower potential to what? To a higher potential, right? So we are going to be having if I should go this direction or I should oppose it depending on what you actually want. So if I go in a clockwise manner like this, the way I went for my first loop, don't forget the longer one is positive, shorter one is negative, shorter one negative, longer one positive. So I'm moving from, let me start from here, right? So I'm moving in this manner. So if I move from higher potential to lower potential, it will be negative. So I'll be having minus 12, right? Now what I'm doing here is applying KVL. I'm only considering only the voltage. Since I'm looking for voltage, I'm only considering the voltage. So I'll write that what? Applying KVL in loop Q R S T Q. Q R S T Q. That's why I'm applying my KVL there. So when I do that, so means the voltage, that means the algebraic sum of all voltage in a loop, in a closed loop, is equal to 0. So this is the closed loop, which is Q R S T Q. Now if I start with that, I'll now have from higher to lower will give you negative. I will ignore this because this is a resistance, this is not a voltage. I'll come here. Now this is what? Positive plus. Now the question is, why is it plus? The reason is this. The direction of the current is coming downward. Look at this is negative, this is positive, this is negative, positive. So we're flowing in this manner, right? And I'm not taking a clockwise direction. So I'm countering the direction of the current here, right? So it will not be what? It will be positive. So I'll be having plus um 0.4 I what? IA, because both of them are sharing one current flowing through this part here, right? And that is IA. So since what is coming down here is IA, so whatever will be coming down here also be what? IA. Now that is telling me that this is what? This is IR. This is resistance, and this IR resistance times current to give us what? Voltage. Can I get that? But this doesn't have any current flowing through because there's already an open loop here. Is that taken? Now we move forward. We're moving from higher potential to lower potential, so we're having minus what? Minus 18, right? Then we're now coming here again. We're moving from higher to lower, so we're having, let's put what? Plus what? Plus VTH. So, or we can say equals to what? VTH or plus VTH. So everything here will be equals to what? Equals to 0, right? So if we do that, what we'll be having here will now be um minus 12 minus 18 is going to give us minus 30. Minus what? Minus 30. Then 0.4, right? Multiplied by IA. What is my IA? Which is 7.458. Right? Minus what? That will now be equals to what? Plus what? VTH. Yes. Equals to 0. Now when you multiply 0.4 times 7. When you multiply 0.4 times 7.458, you'll be having 2.983. So I'm going to be having 2.983, right? So this is what I'm having, plus what? VTH equals to 0. Now negative 30 plus this is going to give us minus what? 27.02 plus what? VTH equals to 0. So the VTH here will now be equals to what? 27.02 volt. That is the VTH. That is the second step, calculating for what? The VTH. The subset, the third step here is now to look for what? Well, we've gotten the VTH. We already have ROL, which is 4 ohms. Now the next thing is what? The RO what? The ROTH, right? So where you can calculate ROTH is for you to short circuit all the voltage source, right? We have how many voltage source? One. Let's see. We have 3 voltage source. 1, 2, 3. So we're going to short circuit every one of them. So when we short circuit, then this is what we're having. Now this is what we're having. So I'll correct what? The ROTH here. Is that okay? Now if you look at this, we'll be starting from this part here, applying your series and parallel rule. If you look at this, the same current will be flowing through this, right? So we'll now be having 5 plus 0.5. That's going to give us what? 5.5, right? So by the time we do that, this is what we will now be having. Just look at this. This is equivalent to this. Now, this is equivalent to this. You know, we've already short circuit all this voltage source we have here, right? We short circuit them. Now, this, when I mean short circuit, means I have removed the element and replaced it with a wire, right? Now I will now be left with this. So this, since the same current, they are on the same path, and the same current will be flowing through them, right? It means they're in series. So what I do, I will now add 5 plus 0.5. I'll be having what? 5.5 ohms, right? Because they're in series. Now what do you notice? this and this are in parallel. So I will now write that my arrow equivalent, right, which will be my ROTH, right, will now be equals to the 5.5, right, is in parallel with the 0.4. Why? Because this is two different parts. So because they're in two different parts, meaning that what? They are what? They are parallel to each other. Then because this is just only in one part, standing alone. So it's in series with what? 0.25. Now when you say something is in parallel, you are going to multiply both of them, right? And you are going to what? Add both of them, add the denominator. Then all adding to what? 0.25. So when you multiply 5.5 times 0.4, you'll be having 2.2 all over 5.9, right? Everything adding to what? 0.25. Now when you now divide 2.2 divided by what? 5.9, you are now going to be having, divide 2.2 divided by 5.9, you'll be having what? 0.372. So I'll be having this to be equals to what? 0.372 plus 0.25. And 0.372 plus 0.25 is going to give us what? 0.622. So we're having 0.622 ohms. So that will be my what? My ROTH that we have here. Is that taken? Now we've gotten the ROTH. Now for we to now apply what we have into the formula here. So we'll now put that. Recall the current that is flowing through the 4 ohm resistor will be the Thevenin voltage all over. So I'm going to put I4 here, 4 ohms. Right, this IL, so the L means the load, which is 4 ohms, will now be the Thevenin voltage of that circuit divided by the Thevenin resistance plus what? The load that we removed. Now when you do that, this will now give us the VTH calculated for earlier was given to be the VTH that we have was what? 27.02. So if I input it, 27.02 all over the ROTH is this, which is 0.622 plus the ROL, which is the load, which is what? 4. And this will now be giving us 27.02 divided by 4.622. And this will now give us 5.845. 5.845 ampere. So that is my load flowing through the 4 ohm resistor. Now what do you notice? So what you notice is that in our previous video, which you can click the link at the top right corner of the screen here, right? We discovered that the current, when we use superposition theorem, we discovered that the current that is I prime prime, I2 prime prime, or I2 flowing through the 4 ohm resistor is given to be what? 5.84. You can just check the video. Just quickly go through the video. You see that no matter the process you take, either you use your nodal analysis, either you use your superposition, or you use your KVL, or whatever you use, you always arrive at the same answer, just like different means to different destination. Different means to the same destination. Is that okay now? So this is the current that is flowing through what? The 4 ohm resistor. This resistor you're seeing here. So the current flowing through these 4 ohms is giving us what? 5.845 ampere. So always remember this formula, and this can be given like this. I have this my voltage, Thevenin voltage, my Thevenin resistance, and my RO load. So this will be my VTH, my ROTH, and what? My RL. That is what this means. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.